Hello everyone. Today, we are going to learn about the delayed coking fractionating tower. Fractionation is a commonly used method for separating mixtures in industrial production. It is based on the fact that each component in the mixture has different boiling points and volatilities. The essence of separating the components of the mixture using a fractionating tower lies in an unbalanced process. It combines multiple countercurrent contacts and heat exchanges between the gas and liquid phases inside the tower. Its essence is an unbalanced process where the gas and liquid phases undergo multiple countercurrent contacts and heat exchanges inside the tower. It combines the repeated partial vaporization of light components in the liquid phase and the repeated partial condensation of heavy components in the gas phase. This process continuously increases the concentrations of both light and heavy components, ultimately achieving the goal of separating the mixture. The oil and gas discharged from the coking drum enter the fractionating tower for fractionation. Compared with ordinary oil fractionating towers, the coking fractionating tower has two main characteristics. Firstly, the bottom of the fractionating tower is a heat exchange section, where fresh feedstock oil exchanges heat with high-temperature reaction oil and gas again. Meanwhile, it also serves to wash down the coke fines carried in the reaction oil and gas. Secondly, to avoid gumming and clogging at the bottom of the tower, part of the bottom oil is continuously circulated through the bottom pump and filter. The fractionating tower in the delayed coking unit serves three functions. The first is the fractionation function. Its fractionation function is to separate gasoline, diesel, gas oil, and part of the circulating oil from the high-temperature oil and gas coming from the top of the coking drum at the top of the tower and the sludge tank into petroleum products with different boiling point ranges according to their varying volatilities. The second is the heat exchange function. After coal tar exchanges heat with diesel at the bottom of the fractionating tower, its temperature can reach 260 degrees Celsius. This improves the thermal efficiency of the entire unit and reduces the thermal load on the heating furnace. The third is the scrubbing function. The high-temperature oil and gas contain a certain amount of dust, which can be settled by the scrubbing baffle to prevent clogging of the trays. Next, let's look at the types and structural characteristics of the trays in the fractionating tower. Common tray types include float valve trays, sieve trays, fixed ton trays, floating ton trays, mesh trays, and three-dimensional ship-type trays. We will focus on several representative ones. The first is the standard disc-type float valve tray. Its main advantages are large production capacity, high separation efficiency, wide operating flexibility, and low tray pressure drop. However, it also has certain drawbacks, such as the easy detachment and jamming of the valve plates. The second is the ADV high-efficiency float valve tray. Its main performance advantages are as follows. First, it has a much higher processing capacity, which is over 30% higher than that of the disc-type float valve tray. Second, it offers wide operating flexibility. Third, it achieves high separation efficiency. And fourth, it has low tray pressure drop. Next is the fixed ton tray. Its advantages include large production capacity, low tray pressure drop, and resistance to gumming and clogging. Nevertheless, it has disadvantages too. One is narrow operating flexibility, large leakage during operation under low gas flow, and incompatibility with towers with small diameters. Then there is the three-dimensional ship-type tray. Its advantages are large bidirectional throughput, high tray efficiency, low pressure drop, wide operating flexibility, capability to handle special substances, low equipment investment, easy renovation, short construction period, and long service life. There are two abnormal operating conditions that can occur on the trays. Let's take a look. The first is bubble entrainment. As shown in the figure, when the liquid flow rate is excessively high on a tray of a specific structure, the overflow velocity of the liquid in the downcomer increases sharply. The gas bubbles carried in the liquid of the downcomer cannot escape in time and are carried to the next lower tray. This phenomenon is called bubble entrainment. The second is mist entrainment. As illustrated, when the gas velocity increases, it scatters the liquid on the tray into droplets and sprays them to a certain height. Some of these droplets are carried by the gas to the upper tray, and this phenomenon is known as mist entrainment. The task of the delayed coking fractionating tower is to separate the mixed oil and gas produced by coking into corresponding coking products. The main fuel oils include the following types: coker gasoline, generally consisting of C5 to C11 hydrocarbons, with a boiling point below 220 degrees Celsius. Coker diesel, typically composed of C5 to C18 hydrocarbons, with a boiling point ranging from 250 to 350 degrees Celsius. Coker gas oil, made up of C20 to C30 hydrocarbons, with a boiling point above 360 degrees Celsius. A typical problem encountered during the operation of the fractionating tower is gumming at the tower bottom. The oil and gas received by the fractionating tower come from the coking drum. If the flow velocity of the oil and gas at the top of the coking drum exceeds the limit, the oil and gas will carry coke fines to the bottom of the fractionating tower, which may then be carried to the upper trays and cause clogging. Excessively high processing capacity or excessive blowing air volume can both lead to the excessive flow velocity of oil and gas at the top of the coking drum, resulting in coke fines being carried to the bottom of the fractionating tower. The gas velocity in domestic coking drums is generally between 0.09 and 0.19 meters per second. Identifying and solving problems continuously constitutes the core of our work. As General Secretary Xi Jinping pointed out in his speech at the National Summary and Commendation Conference on Poverty Alleviation, times create heroes, and greatness comes from ordinariness. Dedication to one's job and commitment to one's post should become the valued pursuit of the younger generation. Well, that concludes today's lecture. Goodbye.